mankind, by prudence of the James Webb Space Telescope, could need to rethink a fascinating exposure. The telescope has revealed a captivating spine-chiller in Proxima Centauri, the closest Titanic star system to us. Amidst Proxima Centauri, the closest star system stands isolated with odd, fake lighting, leaving the Good Instinct region enchanted. Should this be the broad expected demand of untouchable life past our planetary system? How do specialists choose whether those lights propose the presence of sagacious life on Proxima b? As we dive into how the James Webb Space Telescope has seen what might be city lights 7 trillion miles from Earth, clearly, interest in the universe's phenomenal bits of data remains enormous. Mechanical progresses have pushed our ability to examine Earth and the sky, inciting us to explore the vast extents of the universe. Earth remains the only planet known to hold life, and the well-established question gets through: are we revealing the presence of extraterrestrial life, or are their banners just parts of the galactic establishment? In 1984, two American space specialists, Jill Tarter and Thomas Pearson, began an endeavor called the Search for Extraterrestrial Intelligence, SETI. This humanitarian try hopes to channel through significant space radio transmissions, as these signs travel enormous distances and are the fundamental procedure for searching for extraterrestrial modern correspondence. The 42 radio telescopes put in the Californian lowlands were demandingly tuned to the universe's frequencies. These telescopes, known as the Allen Telescope Array, were designed to perceive any sporadic signs from space not enduring broad discernment. No convincing verification of signs from an extraterrestrial human headway has been recognized. Continuous updates from NASA suggest that the James Webb Space Telescope, JWST, could have also seen fake city lights from adjoining planets. This raises the issue of whether the JWST could indeed be mankind's beast jump forward in researching the universe. The JWST is the most advanced instrument in humankind's set of experiences for understanding the universe, arranged around 1 million miles from Earth. This gigantic telescope fills in as our window to the earliest accounts of the universe, giving clearer bits of insight into the improvement of structures, stars, and planets. Arranged with cutting-edge cameras and channels, the JWST enables cosmologists to explore the massive scope of huge quirks by examining explicit light frequencies. The JWST explores exoplanets for indications of something going on under the surface. Its unparalleled ability to peer past typical COF focuses has prompted amazing revelations. For instance, the JWST has perceived a larger number of universes than as of late known, uncovering a deeper perception of the universe's affiliation and headway. As humanity pushes to explore the farthest extents of space, the JWST assumes a crucial role in uncovering the mysteries of distant universes. The revelation of more than 4,000 exoplanets surrounding distant stars shows the amazing headway in our mission to grasp the universe. Red dwarf stars, being more unobtrusive and cooler than our Sun, present prime opportunities for reading up potential livability. For instance, the TRAPPIST-1 system, with its 7 Earth-sized planets, incorporates 3 within the star's livable zone, where conditions could support liquid water. No matter what its cooler temperatures, TRAPPIST-1 produces a fragile, Earth-like light, suggesting its planets could hold life. Likewise, Proxima Centauri, the closest massive star to our nearby planetary group, is a faintly glowing star, and any planet surrounding it would be closer than Earth to the Sun. However, its planets may not keep up with conditions helpful for life. The investigation of exoplanets has opened an enormous expansiveness of possible, revealing different planetary systems beyond our own. Red dwarf stars, being the most widely recognized type in the universe, offer energizing opportunities for finding livable planets. No matter what their cooler temperatures, the TRAPPIST-1 system, with its location and water vapor presence, highlights the potential for life-supporting circumstances. The JWST, with its advanced instruments, continues to transform our understanding by taking apart exoplanet environments and recognizing key particles with regards to organic activity. As scientists explore extreme circumstances on Earth, like those involved by extremophiles, they gain insights into the potential for life in brutal conditions elsewhere in the universe. The investigation of extreme circumstances extends our cognizance of life's versatility and expands the quest for extraterrestrial life, whether microbial life on a far-off world or advanced developments. Each disclosure brings us closer to responding to one of the universe's most profound questions. Humanity's most huge requests are we alone in the universe? As mechanical progressions like the JWST impel our capacity to examine further into the universe, the excursion for life beyond Earth continues to be quite possibly one of the most spellbinding endeavors in science. The JWST, outfitted with best-in-class instruments, contributes to uncovering the universe's secrets and revealing insights into the potential for life beyond our solar system. The mission for extraterrestrial life is quite possibly one of humankind's most critical and dazzling undertakings. As innovative advancements push the limits of what is possible, the James Webb Space Telescope, JWST, stands at the very forefront of this investigation. Its advanced instruments and remarkable capabilities grant specialists the ability to explore faraway exoplanets and their environments in ways previously inaccessible. The JWST's capacity to identify and analyze atmospheric compositions provides critical insights into the potential for life-supporting conditions on exoplanets. By searching for the presence of key atoms like water vapor, carbon dioxide, and oxygen, scientists can derive the probability of habitable conditions. This is especially crucial in the quest for planets that could have conditions similar to Earth, where life as we know it could truly thrive. Not only does it examine Earth-like planets, but the JWST also focuses on more extreme conditions, including those around red dwarf stars. These stars, while cooler and dimmer than our Sun, are the most common type in the universe and often have planets within their habitable zones. The TRAPPIST-1 system, with its 7 Earth-sized planets, is a perfect representation of an objective for such assessments. Regardless of the cooler temperatures of TRAPPIST-1, the planet's proximity to the star and the presence of water vapor suggest that these worlds could support life. The examination of extremophiles on Earth, organisms that thrive in extreme conditions, provides significant insights into the types of conditions where life could exist elsewhere. Extremophiles, which can survive in extreme temperatures, acidic circumstances, or high radiation levels, challenge our understanding of life's limits and expand the range of potential habitats beyond Earth. As our technology advances and our understanding of the universe expands, the quest for extraterrestrial life continues to progress. The JWST, with its cutting-edge technology and ability to look into the far-off universe, represents a significant leap forward in our exploration efforts. Each new discovery, whether it be a distant exoplanet or a novel extremophile, adds to the growing mosaic of how we interpret the universe and our place within it. The examination of exoplanets and extreme conditions not only seeks to answer the key question of whether we are alone but also enhances our understanding of the conditions essential for life. The insights gained from the JWST and other advanced technologies will shape our comprehension of the universe and guide future missions in the search for life. In summary, the pursuit of extraterrestrial life is a dynamic and evolving field driven by advances in technology and our incessant curiosity about the universe. The James Webb Space Telescope, with its remarkable capabilities, plays a crucial role in this endeavor, offering new perspectives and possibilities as we continue to explore the vastness of space. Each revelation brings us closer to unraveling the mysteries of the universe and understanding our position in the grand cosmic scheme. As we prepare the James Webb Space Telescope, JWST, it is poised to be an essential tool in the ongoing journey to view extraterrestrial life and expand our appreciation of the universe. The telescope's ability to investigate the atmospheres of exoplanets with exceptional detail could lead to significant discoveries by identifying biosignatures, indications of something going on under the surface, like specific gases or chemical patterns. Researchers hope to identify planets where life could exist or may have existed in the past. Future missions and advancements in technology will likely build upon the foundation laid by the JWST. New telescopes and space missions are expected to further refine our search for habitable worlds and potentially life-supporting conditions. For example, advanced space observatories could have significantly improved instruments capable of detecting fainter signals and analyzing exoplanets at greater distances. These advancements will enhance our ability to search for life across a wider range of conditions and environments. The exploration of exoplanets in the habitable zones of stars, especially around red dwarfs, remains a priority. These stars offer a one-of-a-kind open door to concentrate on planets that could have conditions like Earth's. Even though they are cooler and less brilliant than our Sun, the TRAPPIST-1 system, with its fascinating cluster of Earth-sized planets, continues to be a point of convergence for stargazers studying potential livability and life-supporting conditions. In alignment with space-based observations, missions to different parts of our planetary system, like Mars or the icy moons of Jupiter and Saturn, will also play a critical role in the quest for life. Discoveries made in our own solar system, for example, potential biosignatures on Mars or subsurface seas on moons like Europa and Enceladus, could provide valuable hints about the presence of life beyond Earth and inform our search strategies for far-off exoplanets. The integration of data from the JWST with ground-based observations and other space missions will offer a more comprehensive picture of the universe. Collaborative efforts among global space organizations, research institutions, and the academic community will be imperative in interpreting findings and expanding new research avenues. The collaboration between different observational stages will help address some of the most significant inquiries in science and space science. Ultimately, the journey for extraterrestrial life isn't just about tracking down different human advancements or life forms. It's tied to figuring out our place in the universe and the nature of life itself. Each discovery, whether it reveals a new exoplanet, a previously obscure extremophile, or an astounding result from a distant star system, adds to a larger narrative about the origins and distribution of life. This journey of exploration enhances our knowledge and inspires future generations to keep pushing the limits of science. As humanity progresses in its exploration of space and expands its understanding of the universe, the mission for extraterrestrial life will remain one of the most compelling and invigorating areas of investigation. The James Webb Space Telescope, with its exceptional capabilities, is poised to make significant contributions to this endeavor, preparing for future revelations and broadening our perspective on the universe in ways we are only beginning to imagine. Each step forward brings us closer to addressing the age-old question: are we alone in the universe, or are we part of a much larger, more intricate cosmic tapestry? As we continue to advance our exploration of the universe, the combination of new technologies and strategies will enhance our ability to identify and analyze potential signs of extraterrestrial life. One of the exciting possibilities is the development of even more complex space telescopes and observational tools. Missions and observatories, such as the Extremely Large Telescope (ELT) and the Nancy Grace Roman Space Telescope, are expected to further expand our capabilities in detecting distant exoplanets and studying their atmospheres. The data gathered by these advanced instruments will provide a more nuanced understanding of planetary conditions. By combining data from various observatories, researchers can achieve a more comprehensive view of exoplanet characteristics, including their true potential for habitability. This interdisciplinary approach will enable scientists to cross-confirm discoveries and refine our search models for life-supporting conditions. Moreover, the examination of exoplanets will benefit from advancements in artificial intelligence and machine learning. These technologies can manage vast amounts of data more efficiently than traditional methods, identifying subtle patterns and anomalies that could indicate the presence of biosignatures. AI-driven algorithms can help prioritize which planets to focus on, further improving resource allocation and enhancing the efficiency of the search. In addition to technological advancements, global collaborations will play a critical role in the future of space exploration. The shared expertise and resources of international space agencies and research institutions will accelerate progress and encourage innovation. Cooperative missions and joint ventures will harness the strengths of various nations and unite diverse perspectives to address complex scientific questions. Public engagement and education will also be fundamental in fostering interest and support for space exploration. By involving the public in scientific discoveries and sharing the excitement of new findings, we can inspire future generations to pursue careers in science, technology, engineering, and mathematics, STEM. Educational initiatives and outreach programs can help cultivate a sense of curiosity and wonder about the universe, driving continued interest in space research. As we stretch the boundaries of our knowledge, ethical considerations will become increasingly important. The search for extraterrestrial life raises questions about how we should approach potential encounters and the implications for humanity. Conversations about planetary protection, the preservation of pristine conditions, and the responsible use of space resources will be critical as we explore new frontiers. Ultimately, the journey for extraterrestrial life is an adventure that transcends scientific curiosity. It reflects our fundamental desire to understand our place in the universe and our connection to other forms of life. Every discovery, whether it reveals new aspects of our own solar system or uncovers distant worlds with the potential for life, adds to the rich tapestry of human knowledge and experience. The future of space exploration is filled with promise and potential, and with each step forward, we draw closer to answering profound questions about the nature of life and the universe. As technology continues to advance and our understanding expands, the mission to unveil the mysteries of the universe will remain one of the most exciting and unprecedented endeavors in history. The James Webb Space Telescope and its successors will be at the forefront of this exploration, guiding us toward new horizons and reshaping our view of the universe.